This is our Experiment 6 demonstration implemented on the Nexys A7 FPGA board with the Microblaze MCS microcontroller IP core being the driving processor behind the operations on board. For the basic I/O configurations, it's based on the specifications, where the least significant switch, J15, is the reset indicator. And then proceeding from there, the 5 next switches indicate, or from L16 to T18, those switches indicate the actual amount that you will be modifying this clock period of the LED shifting. So based on the way that you want to interpret the problem, you can either have that the activation of certain switches in the pattern in the value that is input into the actual board, that can either increase the clock period at which the LEDs are shifting, or that can decrease. I made it as if it were similar to the midterm project where it's a delay, but this is just based on a simple calculation provided in the actual software itself, so it's not something that can't be modified extremely quickly based on whatever the needs are. Right now I have this outputting to a console message for PuTTY as well, connected through serial interface, and right now there's no message because I have that if the reset switch has been asserted, I don't want to output a message, because what happens is it ends up just spamming that console window. So right now the least value that can be input for the delay, a value of 0, corresponds to a clock period of 250 milliseconds for the switching of the LEDs. Now, the maximum value at 31 for the input data when all of the switches have been activated is roughly 1 second. So that's the time differential essentially between the max and the min range. And right now, if I throw the reset switch down, it's going to increment at about 250 milliseconds, and I will demonstrate the reset functionality. First, I'll show that after every time this loop finishes, it outputs the console. So we have the UART test, that was the second time that it went through the process, so we have the UART test number was 1. The switch data is right there, the first value after the time value equals output message, and then after the slash there is the actual clock period in milliseconds. So right now, if I come back to the board, I'll demonstrate the reset functionality. Anyways, now if I want to get to 1 second, activate all switches, and now we are switching at a frequency of a clock period of about 1 second. Since I had to use an integer value, or I wanted to use an integer value for the actual calculation of this time delay, it's not entirely one-to-one with 1 second, but it's close enough, and we can see that the value is 31, all switches have been activated, and the clock period is about 1 second, 994 milliseconds. And then I can just do some other values. I don't know, throw in a value of 3, and that's going to give, I'll wait for the loop to finish. So the switch is at 3, which is specified, and we have 322 milliseconds, just about. So yeah, like I said, it can be interpreted either that the switches are going to speed up the period, or the switches will delay the period. And just keeping in unison with what was performed on the midterm, I decided to just keep it as a delaying function rather than a speeding up function. But that's about it. Thank you.